Okay, I'm just going to talk you through a few questions on factorising trinomials. We have done this before we finished up for Christmas, so none of this is actually new, but just a wee recap today on what you've done. It's important you understand the process for these things before we move on to more difficult ones, so I'll just talk through these three examples below. Okay, so first thing we need to do is recognise that we're dealing with a trinomial. We're dealing with a trinomial, or what's called a quadratic, because we have a squared term, a letter term and a number term, and you must have that to apply this factorising technique. Just remember, guys, that just because you have three things doesn't mean you've got a trinomial or a quadratic. You have to have a squared term, x squared, a letter term, in this example 7x, and a number term, in this example 12. Okay, once we've identified that it's a trinomial, we still look for a common factor. That's still the first thing we look for. We don't have a common factor here, so we move on to our technique for factorising trinomials. Now, like I said, we did this before Christmas, and the process that we used is called the factorising square. So, to start off, what we do is we look at factors of, and it's always the squared term. So in this example, I'm dealing with x squared. So it's two things that multiply together to give me x squared. There are only two things that multiply together to give me x squared. That's x and x. I'm using a dot instead of multiplication just so you don't get x's and multiplication signs mixed up. Okay, so the next thing you do is you look at factors of the number term, the last thing in the trinomial. And you just go through all the factor pairs of 12. Okay, so you've got 1 times 12, you've got negative 1 times negative 12, you've got 2 times 6, and you've got negative 2 times negative 6, you've got 3 times 4, negative 3 times negative 4. Okay, 4 does go in, that's the next number up after 3, we've got that repeating factors, so that's all the factors of positive 12. Okay, when we were in school at this stage, what I was actually trying to do is encourage you to look at what you're looking for. So the way this works is we do a cross multiplication and we add, and what we're looking for is the middle term, which in this example is 7x. So if I look at the factor pairs I've got, we can immediately rule out one type of factor pair because this is positive, positive 12 is positive, and we're looking for something positive. So straight away what I can do is I can rule out all the negatives. Okay, now what I'm looking for is a factor pair that I can get 7 from. Now the one that jumps out to me is 3 and 4 because 3 add 4 is 7. Okay, if I look at the other ones, 1 add 12 is not going to give me 7, 2 add 6 is not going to give me 7. So 3 and 4 is probably going to work, but we can check that using the factorising square. So the factorising square works as follows. You put the factors of the squared term, x squared, on the left-hand side, and you put the factors of the number pairs that you're using on the right-hand side. So in this example, we're using 3 and 4. Okay, you cross-multiply. And you add. And if you've done it correctly, you should get the middle term, which we do. 3x add 4x add 3x is 7x. Now the reason we do this factorising square is because we now have the double brackets, okay? And remember that is positive 3, so that's an add in there, and positive 4 in there. Now remember when you factorise, you need to write out the two brackets right next to each other, so that becomes x plus 3 times x plus 4. And that's the first one done. Okay, the next one. Same starting point, we'll start off with the factors of x squared. Again, we've only got 2, x times x, and then we'll look at the factors of the number term, which in this example is negative 12. Okay, so we'll run through all of them. We've got 1 times negative 12, we have 2 times negative 6, and 3 times negative 4. We can also have that the other way around, so I can have the negative 1 times positive 12, I can have negative 2 times positive 6, and I can have negative 3 times positive 4, just switching which of the numbers is negative. Okay, so all those numbers multiply together to give me negative 12. Okay, again, if you look at where we're heading, we're going to cross multiply in the factorising square, and we're going to add, and we want to get positive x. Now, we've got a kind of negative positive split on the factor pairs here. So 1 is positive, 1's negative. All the way down here, 1's negative, 1's positive. And what I actually want is I want a difference of positive 1 with my factor pairs. So if I look at them, if you add those two things together, you're not going to get positive x. If you add those two things together, you're not going to get positive 1. If you add those two things together, you're not going to get positive 1. Same again down here. But if you look at the last factor pair, then if I add negative 3 and 4 together, I would get positive 1, and that's going to be positive 1x in there. So by doing that kind of process of looking at where you're heading, you can rule out yourself out quite a lot of work, because if I would have had to have drawn 1, 2, 3, 4, 5, 6 factorising squares before I got to the correct one. And you might have to do that to begin with until you get used to it. Okay, so I'm going to jump to the one that works. So I've got x and x, the things that multiply together to give you x squared on the left-hand side. The factor pair on the right-hand side, the things that multiply together to give you negative 12. Cross multiply, 4 times x is 4x. Cross multiply and add. Okay, so that would be the same as 4x take away 3x, which is just going to give me the x I'm looking for. And again, you can see cross multiplying and gives me the positive x I'm looking for. Right, okay then, so as I've said before, the good thing about the factorising square is it actually gives you the brackets. First bracket is x minus 3, second bracket is x plus 4. Okay, last but not least, starting off the exact same way, factors of x squared, the squared term x times x, factors of negative 10. Okay, so I can have 1 times negative 10, I can have negative 1 times positive 10, I can have 2 times negative 5, and I can have negative 2 times positive 5. 3 doesn't go in, 4 doesn't go in, 5 does, we've got it, so we're repeating factors, so that's all the factors to negative 10. Okay, again, you might be able to spot which factor pair is going to work, but you can have a quick check. 1 add negative 10 is not going to give me negative 3x. Negative 1 add 10 is not going to give me negative 3. 2 add negative 5, well that's 2 take away 5. That one is going to work. So factorising square, left-hand side, two things that multiply together to give you x squared. Right-hand side, the factor pair that's going to work, in this example, 2 and negative 5, cross multiply, add them together, and you get your negative 3x. Okay, so again, we know that's positive. Okay, so we've got x plus 2 and x take away 5 in the second bracket. And we can check all these things very easily. If I multiply out any of these brackets, I should get back to what I had when I started. So if I multiplied out that bracket, I would get that. If I multiplied out that bracket, I would get that. If I multiplied out that bracket, I would get that. Okay, you never change the function or the expression when you're factorising. You never change it, you just write it out in a different format, and that format is put in brackets. Okay.